you're going to want. Documentation might vary. Right? That might vary as well. So lots and lots of components other than code. Scripts to populate the database with test data, too, would be another good component. Elements of the smoke test belongs there. So whatever's there, I want to be able to see it. I was happy to see that one of the teams turned in some great sort of zip up of various resources that are required, tests, etc. And that's fantastic. And I would like that. I would like an archive. I don't mean the music. I mean I'd like an archive of the materials for a given turn-in, so that I can access it. I can access it offline, but I do want access to the repository so that I can monitor what's going on. Again, the point of the milestone is not to document. The point of the milestone is to communicate to me, and even more important, to the others in your team, sort of what you've got asset-wise, what the current state of the system is, et cetera, and to communicate to some degree with your other stakeholders. So, I'm not interested in having a lot of elaboration on details of what went on during the inspection or risks. Pithy summaries are fine. I'm quite functional about it, but I'd like to have confidence that you've put some serious thought into thinking about things like risks, thinking about things like a test matrix, thinking about things like, what testing strategy are we going to perform, where might the test hook up, those sort of things. These are great subjects for this deliverable or later deliverables. And whatever you hand in, I just want to, I'd like it to communicate to me in a way that isn't full of ambiguity, sort of what the current situation is. Okay? So turn things in, but don't worry about creating a lot of text for it. Each one of these deliverables takes quite a bit of my time to kind of go through, take a look at what the state is, and a huge amount of text won't make that process any simpler. It'll be just probably, at some point it's really diminishing returns into what it communicates. Any questions on that? Questions on what needs to be turned in for deliverables? What I'm expecting? Obviously, it's going to evolve as the time goes on here. Later deliverables, there's going to be a larger set of stuff, probably a more extensive set of code base, to be sure. Larger sets of tests, more extensive smoke test, because the functionality of the system will be growing. And to have confidence that it's basically working, you're going to be poking more things. But any questions on deliverables in general, what I'm expecting? Yeah?
Do you want us to, pretty much, everything in the syllabus you want there, you want in the document? Because it was quite a bit, of stuff.
Indeed. So the syllabus has bullet points, right, on sort of what's expected. Do I want everything in that syllabus documented? Not necessarily. I'm not going to look for one-to-one correspondence. However, it would be in your interest to make sure that I'm clear that if you have if you have coverage testing mechanisms in place, I view that as a real asset, and I view that as important, and it's in your interest to communicate to me somewhere that that's in place. And I would like to see it in the turned-in deliverable, but at the least I'd want to see it discussed in terms of the presentation. It's not in your interest to do, to put in something in place that I would really think highly of, but not communicate it to me, right? So I don't expect you to use that syllabus as a checklist that, here he mentions mocking. We have to have it in every report. Because, let's be frank, at this point, it'd be great to have mocking, in frameworks. It'd be great to see a lot of code written, but for a first deliverable, I'm not expecting a huge amount along these lines. But as you add things in, yeah, start to put them in the report. And by deliverable 5 down the road, I'd be surprised if most of those things aren't mentioned somewhere because they're relevant for success in this enterprise. But I'm not saying for every deliverable you have to hew to exactly that list. Does that make sense? Yeah. Other questions? Okay, but what I really do, is it Jordan? Yep. Yeah. So what I really like about what Jordan's asking is, do remember the syllabus is an asset. You go back to the syllabus and you'll kind of see things laid out. And even if you don't use it as an exact guide, oh, we left that out, we have to put it in. Don't necessarily use it like that. But go back and check it. And if there's something that's mentioned there that you aren't thinking about, you should really start to think about that soon. Because maybe it's something that could be important for your success going forward. So try to refer back to it. And similarly, there's some text in the syllabus about kind of what's expected for the project, and it might be good to review that and try to remind yourself of some of the things I've requested. Okay? Okay. Good. Any other questions? Question? No. Okay, we'll wait on that one. Yeah?
Could you talk about projects like CPM schedule a little bit, like what you expect?
Sure. We're gonna have a lecture on that, but I haven't covered it yet. I will be covering it probably right after the break. What that involves? Okay, so suppose you have we're going to be talking after the break about two processes that are pretty important traditionally within projects. One of them is a process known as estimation, which is associated with estimating the amount of time that a given task will require to complete. And humans are really poor at estimation for many reasons. We tend to be very ill-suited to kind of guesstimate how long certain tasks will take. We tend to be over-optimistic. We tend to be over-optimistic of how confident we should be about our estimate. And we tend to be systematically off in a direction that's least advantageous, that puts it at most risk, namely underestimating. And there's many psychological and contextual reasons for this. But this is one of the topics we'll be discussing. But a second topic will be scheduling. Okay. Now, if you have a set of tasks that are estimated in terms of the amount of time that they'll take, T1, T2, T3, T4. And let's suppose T1 is 10 hours. Let's suppose T2 and T3 are 3 and 3. And let's suppose T4 is 4 hours. That's estimated to be required for that, right? How long is it going to take me? Phrasing this ambiguously for a reason. How long is it going to take me to complete those tasks collectively?
20 hours.
Good. 20 hours. Just sum these things up, 20 hours. Now, is that 20 hours of clock time?
How many people do you have in your team?
Okay, that's a good question. What's another question?
How many of them are dependent on the other?
That is even deeper question. Let's suppose T4 depends directly on T3, depends directly on T2, depends directly on T1, in the sense that it can't be started until the previous one is finished. Can't start T sub I until T sub I minus 1 is finished. What would that imply about the total length?
Then it's 20 hours regardless of how many people you have.
20 hours, yeah. By the way, I'm really oversimplifying this in the sense that one of the lessons coming out of estimation is you try to avoid point estimates. You try to avoid estimates that are just single numbers. you try to give range estimates that have some bounds of uncertainty. But just for the sake of this discussion, for this particular point, I'm going to say, okay, if you had linear dependencies, if this depended on that, then it's going to be 20 hours of clock time as well as 20 hours of work. But let's suppose that T2 depends on T1, but none of the other later T sub 3 and T sub 4 depend directly on each other. How long could this take then? 13 hours. Good. Good. So we have here task 1, right? And now we have task 2 that depends on task 1. And then we have task 3 and task 4 that each depend on task 2. And once we're done with completing all the tasks, I'll draw sort of a transition here to the finish, right? Big smiley face. Okay. So that's our finish. And in terms of total amount of time, we have 10 hours here, we have 3 hours here, and then we have, what, 3 and 4. But Warren had the essential idea here. You know, T2 depends on T1. Excuse me, I said neither of these depend on each other, didn't I? So we've got something like that. That's great. That's great. So how long can this will this take? If T3, T4, T2, T3, T4 are all independent, how long will it take to finish then? 14. It's actually the max of these, because these are going on. It'll be much easier if I drew it out properly here. Excuse my lack of lucidity there. So here we have T2, T2, and we have T3 here, and we have T4. And to sort of make the point more clearly, I'll draw T4 as if it's longer in time. And then we have this finish here, right? And so this is the rate limiting step. This is called, anyone know what this path through here is called? It's called, begins with C, 2 words. And the second word begins with P, critical path. This is the critical path. What does that mean, the critical path? It's the limiting path. Okay, let's expound on that some more.
That means that it doesn't really help to increase the efficiency of the non-critical path.
Okay, so any delay in the critical path will delay the whole project. If you delay the critical path, you're directly delaying the finish of the whole project. Let's suppose I were to delay T2 by an hour. Is that a problem? No. I have slack with that. I have give. I have latitude. I have float. It goes by different terms. But the basic gist is T2 and T3 are different than T4 in the sense that they have some flexibility about when you schedule them because they won't be the ones delaying the whole project. This T4 is the one delaying the whole project, the completion of the whole project. And in scheduling, and particularly mapping out this sort of diagram, tasks, dependencies between them, and times associated with them, and reasoning about it using a simple algorithm, a linear time algorithm, is the essence of the CPM method, critical path method. This is a critical path method for identifying what is the critical path. And it's a useful technique, particularly because it allows you to identify the critical path. The critical path is the one we can't screw up. We've got to keep on top of it. If we screw it up, we're going to be pushing things off about the whole project, the completion. Think about the whole deliverable, being delayed because of it. Whereas these other things, we have some latitude for when we can schedule those, etc. So critical path method, I'm going to be presenting a whole lecture on this about the algorithm for identifying the critical path, figuring out the minimum time required. And it's a sort of thing we're familiar with from day-to-day reasoning and common sense terms, but we'll be formalizing it. And as far as deliverables, involving CPM diagrams, what I would love to see would be, and this is not something I'm saying is absolutely essential, okay? But what I'd love to see is some thought as to what the tasks are in a given deliverable and what their dependencies are between them. What depends on what. If you need to get Merlin to set up this VM so that you can, install a build server, so that once that build server is installed, you can install cruise control on it and go on. And you've got a series of linear dependencies. That has a lot different implication than if you can do things in parallel. And I'm asking for some thought about what the critical path is. Past teams have said that without understanding the critical path, they would have felt really in jeopardy in this class. So it's an untrivial concept, and it can help guide your efforts. You can slack off a little bit, or I shouldn't say slack off. You can devote, you can shift effort sometimes from non-critical path things to the critical path. You can monitor, is something coming into the critical path in terms of it's taking a lot longer than we think, and now we think it might delay the whole project. And that can allow you to make better decisions about where you're devoting your efforts. Does that make sense? So we'll have a lecture about this. You'll find lectures of me talking through this material online if you'd like to go watch it. But it's a pretty intuitive set of ideas that, again, we use day to day, but putting some thought into the tasks and their dependencies between SIM and what it means for the critical path. That's the main thing I'd be looking for there. And it is a request. It's not an absolute requirement. Okay? Other questions? Good. Great. By the way, I am asking for this. I'd only be expecting to think about that on a per deliverable basis, not for the whole semester or something. Yeah. One of the big points of multiple deliverables is we learn in the process, and your estimates now of what may be required task-wise, a month from now, will probably be very, very different based on the learning that's taken place since then. Okay? Okay, great. So I asked you to go over some examples. I asked you to go over some examples of the Liskov substitution principle. And I'd like to walk through those examples and to sort of exercise our thoughts. And then we'll be expounding on this some more. So I guess first, why the Liskov substitution principle? Why am I spending a couple lectures on this principle?
Because it's important, and it's especially important.
It is. It is. That is that's the most important thing.
I mean, it's especially important for some of the object-oriented languages that we're working with a lot.
That's right.
Java.
That's right. That's right. And what is it? What does it involve? Yeah.
It formalizes the notion that a subtype should be a type of the supertype.
Good. So it formalizes the notion of safe subtyping, of using polymorphism in a way that's safe, right? So if you can pass around, if you can declare one subtype, B as a subtype of A, that allows you, and in a language that supports polymorphism, it allows you to do what? To pass around an instance of
B as A.
B as if it's an A, right? And to be used in code that manipulates A's. And that may have been written long before P ever existed by people who never knew that P would come about. So you've got code that's depending on these A's, and you've got these B's masquerading as A's. And the question is, how can we do that safely? How can we do it in a way that's robust? How can we do it in a way that won't break code that's been around long before our class gratuitously? Okay, so it's the key for reasoning safely about types in the presence from polymorphism. And we said it's up to do with these properties. If you could prove properties about the subtype, here called D, about C, those should be also provable for D. We should be able to do things with D that we are confident will work with C. They're properties that, based on the specification of C, based on what we know about C, we may reasonably be counting upon. That sentence gave me the willies, but it'll do. Okay, so the situation that we think of is sort of the canonical situation. Suppose we're a programmer, and all we know is that it's a C. And somewhere else in the code base, someone passes us something that's secretly a D. That's what's shown here. Foo is secretly passed to D, unbeknownst to the people who created it. Again, D probably didn't exist when foo was created. And suddenly they're being passed this thing, D. Could the people who wrote foo, years before D was a speck in the cosmic eye, could those folks be rudely surprised? Could they feel like their guarantees of C have been violated? Could they feel that their understanding of what's legitimate about C has been somehow rent asunder by this D? Not if it follows the Liskov substitution principle. Exactly. So it's not just about being picky. This is about avoiding breaking code. This is about avoiding subtle bugs. This is about avoiding people who try to extend your system instead breaking it. And it's a very practical thing. It's not about, pristine notions. It's about, look, if someone has certain information available to them and they come to count on it, you don't want to gratuitously break their code. Okay? If you do, errors and rework will result, and it may break code that was safe and sturdy long before you introduced a subtype into the system. Okay, we're going to come back to some points for reflection, but I want to talk through these examples that I gave you. So, here's a supertype, and here's a subtype. Is this a legitimate subtype of this supertype? Well, okay. Yes. Okay. So, yes or no?
No.
Why not?
It breaks history because
Good.
if you look at it over time, it might decrease it.
Good. So we talked about three corollaries for the Liskov substitution principle, and they involved something about the signatures for it, right? And then something about the methods with preconditions and postconditions needing to be consistent. And then something about the invariance and history properties, the things that apply at the level of the whole class, variance and history properties. And what Warren has pointed out here, which is exactly correct, is that this violates a history property. And the history property is that this can only...
it can only go up over time. It can never go down.
Yeah, it can never decline. It can only stay the same or rise, right? Yes, correct.
So if you wanted to actually have this type of functionality without introducing code clones,
Yes.
and you can't make this a subtype of counter, then what would you do?
We're going to be talking about that.
Okay.
You can use mix-ins. You can use skeletal implementations. You can basically reuse this code in a safer way, just not with subclassing and subtyping.
Sure.
Okay? And we'll see how to do that. You could create a wrapper class that inside has an instance of the supertype, but it provides a different contract altogether. It's not a subtype of, it's not a subclass of this counter, but it calls internally the methods of counter with abandon. Okay? Okay.
I await the information with bated breath.
Okay. That's good. Okay, so that's great. So here's another example. Okay, this one is not in This is not in the take-home, but it's to reinforce the point. Okay, so here's the super type. Counter. We have a get, and we have an increment that I explicitly say adds 1 to the current value. You notice in the previous definition that was a bit vague, right? It said incremented. Do you think it's possible that somewhere out there in the code bases that circulate there can be ambiguity like that? Yeah. Yeah. A lot of ambiguity. And do you think it's even possible that sometimes there might not be formal specifications? There might not be even, informal Java doc specifications? Is that possible? No. Oh, man. Okay, yeah. I mean, for the undergrads, hold your chairs and prepare to be shaken. It's a nasty world out there, and there's lots of code that's not well documented. So what do you rely on if you don't have explicit comments that give these sort of specifications? Interpretations through things like names and some documentation that might be in the form of a separate document that says roughly what the purpose is class is. So there's a lot of ambiguity, and I'm just trying to highlight the fact that doesn't mitigate the need. In fact, it increases the need for thinking seriously about what someone could be reasonably inferring. Okay, so let's take the super type here. Counter with get and increment. And here I'm very explicit. It adds 1 to the current value. Now, here we have a proposed subtype that extends that, but it provides one new method. This is just a constructor. Provides one new method, increment 2. And it adds an arbitrary n greater than or equal to 0 to the current value of the counter. Is that a legitimate subtype? No. Why not? So give a case where someone could be reasonably shocked if they secretly have one of these and they just think they have one of these.
Well, let's say you have something that counts the number of transactions that you're using.
Okay.
So you rely on a counter. So every time you use a transaction, it atomically makes it increase it by 1.
Okay.
And then somebody else uses it as a counter 3, like counter 3,
okay,
and increases it by some large number.
Okay.
That would totally throw everything back because there's just this massive space of transactions that don't.
That's technically a Liskov substitution, though. That's multi-threading problems.
Okay. So I'm hearing some sort of back and forth on this, and this is interesting. This is a bit of a subtle case, and I wanted to talk about it. There's a comment over here, too.
Well, I was just thinking that it might not, I think it might be legitimate.
Okay.
The increment function would still work as normal. So if you were using it as a
Okay.
D, hidden as a D,
Yeah.
it would still work exactly as you would expect it as a C, would it not?
Okay. So let's put it this way. Could, with this subtype, hey, come on. With this, could you get a value that you could not have gotten with this? So suppose somewhere else in the code it knows it's an increment 3, and it increases it by, something that's less than 2 to the 31st. It increases by some huge value, right? And it's still legitimate integer above 0. But it increases by 10,000 or something like that. Could you have gotten, and yet the code that's thinking it's one of these guys has that value after that's been done to it. Could that have been obtained by calling this many times? Yeah. It could have been. So could someone who is expecting it to be this, but instead it's this thing, say, like, this is impossible. There's no way that could have resulted from this? No, the answer is no. And I think what Connor was getting at, and I think what Warren was thinking about were two somewhat different situations. Remember, somewhere in this code, it thinks it's a C, right? And it's counting on it having all the properties of C, all the features of a C, all the behavior expected of a full C, right? And the issue is that somewhere else in the code base is created as a D. It's created as the subtype. And it knows it's a D there. And it calls this increment2 method, which increases it by an arbitrary amount greater than or equal to 0. So somewhere else in the code, maybe on a separate thread, maybe elsewhere in the code base on this thread, something, maybe foo calls off to zap, which calls off to baz, which is calling bar, and it's manipulating it as a D in all of these things. They know it's a D, and they're adding things to it. But when it comes back to foo, which is thinking it's a C, it's a value that could have been produced perfectly well via this if enough calls to increment were had. Instead of incrementing by 10,000 at once, it would have had to call incr 10,000 times, but it could have been produced. So in short, ladies and gentlemen, is this a legitimate subtype? Yes. It actually is legitimate. It doesn't violate a history property. It still can never decrease. You have time 1, time 2, and time 2 is greater than time 1. The value at time 2 can only be equal to or greater than the value earlier. But it could be a lot bigger, but it could have been a lot bigger through this interface. Does it violate an invariant, something that you can assess at any one time? No. It always is greater than or equal to 0, just like the original one. And in short, it hasn't broken anything. It's provided extra functionality without breaking the assumptions. Does that make sense? Are people comfortable with why this is OK, but this is not OK? Yeah? This is violating a history property. OK, good. So how about, sorry, oh, it looks like it repeated. OK, how about this, dual counter? So here it extends counter, and it provides an extra counter. It's maintaining 2 counters. And this one has get, just like the original counter, and increment, to increment that counter 1. But it also has get 2 and increment 2, which are affecting the second counter.
There's no history properties on get 2 or on the second counter. So there could even be a decrement 2, and it should still be OK.
Yeah.
That's true.
Any code that was made for counter could call the exact same functions and just be unaware that it would
Totally. Totally. This is perfectly fine. This is perfectly fine. You've extended it with a lot of extra functionality, so to speak. But there's no violation of the original properties. You have this extra counter, but that doesn't interfere at all with the original, right? Does that make sense? Now, I liked what I heard earlier. You could have a decrement for counter 2. Could you have a decrement for counter 1?
No.
No. Why? Because then we'd be violating the history properties that someone's counting on for counter. OK, how about this one? Ebulliently, we exuberantly, we push our functionality forward. We have a swappable dual counter. What's the problem there? History property. Now we swap the 2 counters. Something that was going up suddenly goes to 0 because we swapped the counters. So this can break the Liskov substitution principle. Do you see that? People, any questions on that?
You could put excess limitations on it so it wouldn't break the principle. But
That's right.
it would make it kind of
That's right. That's right. For example, we could only swap into counter 1 if the other one was equal or bigger in size. That's right. OK, so here we have an int set. Whoa. An int set, and here we can insert, remove methods. We can ask if a given element is insert and remove elements into the set. And this is a set. So it's an unbounded set of integers, a mutable, but no upper bound on its size. It is mutable, so you can insert and delete things into it. You can ask for its size. You can iterate through its elements, et cetera. And we have this set. And let's suppose now we were to go and want to create an int bag out of it. This is identical, except you can have multiple inserts of identical integers, and they're kept track of independently. So if you insert twice, you have 2 of them, not just 1. Would that be a legitimate subtype of this?
No.
So you add twice, remove once, and what would that have yielded? So suppose you were to add 1 2 times over. You call insert of 1. Then you call insert of 1, and then remove of 1 on a true inset. What would you have? Would 1 be in the set or no? No. How about in this int bag? It would be in the set. So someone could say, they could stare at this code all day, this code they've been trusting for 10 years to work, and say, this is impossible. You know, there's no way that I can add this in and not get out a value. And it's just because somebody somewhere said, oh, let's make an int bag and pass it around as if it's int set. What the hell? And they end up breaking their code. Yeah.
I'm just wondering if you would ever have an example where you expect your int set that you would be trying to insert this same element into it twice in a row and then be surprised when it's still in there after all the loop.
Well, let's put it this way. You might have code which in a loop, you know, is processing numbers in a file, and it's just accumulating the set of all unique numbers which are in this file, independent of order. And each number you read in, you just insert. You know, you have this int set, and so you're just inserting them one after the other, knowing that it's going to take care of duplicates. And then later you kind of go through them and remove certain ones or something like that. And that could lead to some violation of this expectation that inserting it multiple times doesn't matter. It's idempotent. You do it several times, it gives the same thing. Does that make sense? Are people comfortable with that? Yeah, okay. Okay, good. Here's course reporting timer, find timer. Okay, so here's this course reporting timer. I think I renamed it since I gave it to you, just to be clear. So this timer, basically, we begin it by the constructor. We create this object, and it's keeping track of the amount of elapsed time since it was created. That's its job in life. And how do we know that's its job in life? Because we have somebody gave a little bit of thought when they put hours. It returns the total elapsed hour count rounded down since the object was created. And same thing with minutes. Okay, so we have this little thing. We can ask hours, and we can ask it minutes. Man, I'm glad that person put in these comments there, because otherwise, who knows what hours? This is record the current hour of the day. You can't tell from that name, but they put in these comments. That's great. Okay, so imagine we have course reporting timer as our super type. Now we have a find timer that depends on this. And the find timer should be called find reporting timer, excuse me. But it provides that functionality, and it has a method seconds that returns the total elapsed second count. So it extends this functionality of course reporting timer by providing another way of measuring time, namely in seconds. Is that a legitimate subtype? Yeah. Perfectly so. Great subtype. Useful, fills in a need functionality-wise. No problems there. How about modulo timer? So here we subclass this one, the course reporting timer. But here, we're going to override minutes. We're going to override minutes to return the number of minutes, not sort of counting hours. It's the number of minutes within the full hour. So in other words, if it's 1 hour and 40 minutes, we'll return 40. If it's 5 hours and 33 minutes since it was created, we'll return 33. Is that a legitimate subtype? Okay, so what's violated there?
The expected behavior that we think we would if we called reporting timers.
Okay, so that's good. I would say there's two issues.
We're not sticking to the super contract.
That's right. Okay, and there's two issues. I mean, one thing you could say is, well, it violates a history property. Here you're counting on minutes only going up, right? And so it's a violation of that, and that's true. But there's another violation, too, which is, in terms of the methods, the method preconditions and postconditions are totally different. This is not, the postcondition of this minutes is not a strengthened version. It's not a more specific version of subset of the precondition for this guy, or the postcondition for this guy up here. By contrast, it's a totally different sort of beast. It overlaps for the first hour with what this does, but outside the first hour, it's just giving totally different answers. So this post condition for minutes here is in violation of the post condition for minutes up here, the implied post condition. You know what? The post condition is not stated implicitly, but that doesn't get you off the hook. The point is someone could reasonably be working with this interface, have been working with it for 15 years, and be expecting that it will work this way, and suddenly something's passed into them saying, I'm a course reporting timer. And they said, from your behavior, you ain't, and you've broken my code. Okay, how about pausable timer? Begins the timer and pauses it. No, why not? Yeah, okay. Yeah, exactly. It's no longer now. So it hasn't overridden minutes, but it's frobbing these other methods. But no longer does minutes return the same thing. Minutes is no longer returning the amount of time since it was created. It's now returning the amount of time it wasn't paused since it was created. So it changes the semantics of what that means. If you pass this in to someone, you'd get weird things going on where, it's the same for hours and hours and hours in value, and suddenly it's changing again. Weird stuff. How about resettable timer? No, it's also in violation. People comfortable with this? Okay, you can almost bet that there'll be questions like this on the final. I mean, basically, there are going to be questions like that. Quite a few. Okay. Okay. Here's integer bag. I think this is basically what we had earlier, so I'm not going to go over it. Okay. Yes. Oh, here. Okay. No, this is actually different. Okay. Here's integer bag on the left. So we have a bag. And we want to create a set out of that bag. Is this a legitimate subtype of bag? So you think you have an integer bag where you can add things in multiple times, and they'll be counted for each time. And if you want to remove them fully, you have to call remove as many times as you added it. And we want to build an integer set on top of that, where it's you add it as many times, and it's only the effect is only adding it once. And we do that by saying, for insert, we have a stricter precondition. We say, we're only calling insert on this integer set if it's not already in the set. Can we do that?
Nope.
No. Why not?
It'd be better as a wrapper sort of thing you were mentioning earlier.
Exactly.
Set
Exactly. It's not a matter of forever forsaking the functionality of insert bag and saying, suck it up, we got to implement this totally from scratch. It's a matter, we can't subtype it. We can't pass this around as if it's one of these. Because someone having an integer bag, they might have comfort in noting that they're going to call this method every time, and each time it's going to be keeping track of a different one, and they call it an integer set, and it blows up in their face. It says, no way, Jose, and it bombs out. It violates an assertion. That would not be a good thing, that their code is broken by this thing that's claiming to be an integer bag. So in short, ladies and gentlemen, polymorphism provides huge opportunities to reuse code written against supertypes using instances of subtypes. But it only is going to work. It's only going to be a viable strategy. This type of situation is only going to be a viable strategy if D adheres to it's a true behavioral subclass of C. If an instance of D adheres to the properties we can prove to an instance of C. We don't want to rudely surprise people. Does that make sense? Questions on this? I'd like to have a few reflections before we go on to this next issue. Okay? We're going to be talking next about subclassing, which brings in a whole nother level of issue. Okay. So, key points for reflection. Interface specifications are contracts. They're promises that must be adhered to. And I don't care if you write them or they're just implied. They seem to be implied by your method names and so on. The point is, when you write code and someone's going to subtype it, or someone's using, excuse me, if they're using instances of a class where you've declared some methods in, they're going to be coming to study what methods are available and potentially making assumptions about how instances of that class should behave. What instances of that class can do. What it's possible to get as a current value of that class. And if you write out specifications clearly, those promises that you're making are more explicit. They're more clearly delineated. They're more. They are more like a formal contract. If you don't write out those specifications, people will still come to conclusions about your class, and it's in your interest to try to delineate what they can count on and what they can't count on. Why is that? Why is it in your interest, if you write a class that is to be used, that you make clear what can be counted on and what can't be counted on? So suppose you go and you write a class C, and you have a bunch of methods in C. Why is it in your interest as the creator of this class for people to be very clear about what's promised and what's not promised by those methods?
So that if you're using stuff that inherits from C, you won't break your code.
Good. So one thing is if you're writing code that inherits from C or some type of C.
No, I mean, if you've written C.
Okay.
And then you've written presumably functions that also do stuff on C.
Yes.
And someone gives you something that's
Good.
a C, but it's actually a D.
Good.
It won't break your code. You can be sure that it's actually
That's true. So if people are passing around Ds as if they're Cs, it's very important those people who write who define these D classes are clear about what's needed to be compatible with C. But it goes beyond that. Why else would it be important?
You can control the specification, but you can't control assumptions.
Yes, that's right. With the specification, people, if you explicitly write out the specification, it will be more clearly laid out what they can count on and what they can't count on. And what they can't count on are things that you have the flexibility to now do what? To change. You have the flexibility to evolve. You don't say whether the sort routine is a bubble sort, an insertion sort, a merge sort, a quick sort, a radix sort. You don't need to specify that in your specification. You just say it operates to sort these integers in a way, and you make no statement about whether repeated integers, integers which are members of this array, are guaranteed to be in the same order, and people shouldn't be counting on that. If, on the other hand, there's no declaration of this, what might they do? Make assumptions that you don't want to promise long term. Assumptions that are counted on and seem safe for the current implementation, but which you may change later. You may break later. Yes, Warren.
And ultimately, if you don't specify it, then you realize, oh, I have to change it. So you'll be breaking a lot of stuff.
That's right.
Specify it.
Precisely. But if you specify it, if you say what they can count on, or per Kurt's comment from 1 or 2 times ago, if you specify what they can't count on, that's perfectly legitimate. Say, you should not count on the fact, the certain behavior of the class. It's now much clearer what's fair game as far as your evolution of the class. And it's clear what they can count on and what they shouldn't be counting on, so they have greater confidence in creating their uses of their code, which uses your code. So, in these specifications that we provide, who uses them? Users of instances of the class, people who use these instances that want to know if I call foo or I call bar, what do I get back? What does it require as arguments? Maybe now it accepts null methods, but maybe in the next version of the library that's provided, null references to be passed in, but maybe in the next version of the library it won't. And if you have a specification, it will lock in behaviors you can count on. So people who use your class, who use C, will have an interest in you having clear specifications, but also creators of interfaces of subtypes. So people who create Ds that are subtypes of C, they're going to be also counting on how C can possibly behave so that they can adhere to it. And finally, the people who create superclasses of your class, of whom your class is a subclass, for example, they're going to want to have confidence that if you've overridden certain methods within your class, that their functionality of the superclass is still going to work okay. Okay? So we're going to go into that in just a few minutes here, get a glimpse of that. But let's be clear about this. Not providing a clear specification worsens the problems. The promises you're making are unclear now. They could be counting on functionality just by experimenting with your class and saying, oh, looks like it takes a null reference just fine, so let's pass it a null reference. Next version of your code base comes out where it can't be null and their code is broken. You are making unclear promises. They are coming to conclusions about promises you may not have desired to make if you're not documenting your specifications. Okay? So, here, when we've been talking about the Liskov substitution principle, we've been talking about the promises made by subtypes compared to the promises by supertypes, the contracts in place. We are next going to go on to talk about subclassing, which brings a whole other level of sort of texture to the issues. But the Liskov substitution principle fundamentally is about the promises made by D compared to the promises made by C. The promises made by D must be consistent with to those of C in these different ways. All the properties that are provable of C must hold for D, and that includes invariance, history properties, things that are true about the whole class, things that are true about methods in terms of preconditions, postconditions, and the signatures have to be compatible in the sense that contravariance, covariance, so we saw last time. That's the Liskov substitution principle. Any questions about that? Yes, James.
I'm thinking of a case where we have this class,
yeah,
a report, this class report, and subclasses like XML reports,
yeah,
like JSON report, for example.
Sure.
And we have an reading method called toString.
Yeah.
And each toString gives the format of the subclass.
Yep.
And this class also has toString, which gives a default format.
That's right. Yeah.
Without the violation of the Liskov principle.
Would that involve violation of it? No, because it depends what promises are being made for the superclass. I mean, typically in a toString declaration, you wouldn't say that the results of calling toString must be in exactly this form. What you'd say for the postcondition for that is something like it returns a representation of the current object and as a string.
It might have a size limitation. Like it could, if this is something that's meant to sit inside of an int 256 of the MySQL database, then you might say the toString output can't be bigger than 256.
Sure.
Bytes, for example.
You might say something like that, but generally speaking, it will be. I mean, after all, toString for certain objects will return different things. So you're not going to say exactly what it returns. And typically for a superclass, it's going to be quite broad in terms of its description. And the subclass is not going to break that.
What about the case where the base class has access to a database,
Right.
and it returns something?
Yep.
So the superclass returns the variant of itself, like from the database. But we all have access to the database.
So say that again. I didn't get that. I thought you said the base class.
The base class has
Is base class the superclass? Or is it the subclass?
So A, for example.
Yeah.
Okay.
as a method
Yeah.
gets some things from the database.
Yes. Okay.
B
It has fetch, a method fetch, which gets it from the database, and B has.
write fetch
Okay.
gets something relevant to B from the database.
Okay.
Yeah, is there a violation of this?
Well, again, I mean, the question will be, what is being promised by fetch here? If you say fetch here, returns a certain field from the database, the value of a certain field, and you have a different field being gotten by B, for example, or it's relying on, a totally different component of the schema, then that would be a violation. On the other hand, if fetch is simply saying, instantiates the current object with data from the database relevant to it, then this would be a perfectly legitimate specialization to the case of a B. It would have corresponding data from the database needed to instantiate a B or something like that. So it would be consistent. But a lot of it would be about what promises are made, what guarantees are made here, and could someone be rudely surprised if they secretly have this? From the sound of what you're saying, I'd be surprised if that's the case, because you could have it be perfectly consistent. Is that helpful? But don't get me wrong. There are cases historically of class libraries where there have been violations of the Liskov substitution principle, and programmers have cursed them for it, because you are passing around an instance of the subclass as if it's an instance of the superclass, and all the things you're counting about, or many things you're counting about about instances of the superclass, are no longer the case. And that has occurred commercially, and those frameworks have generally not done very well. One of the reasons Sun has done such a good job, and I think the .NET library, is because they've been much more careful about these things. But it is a phenomenon, and a lot of the reasons for it is they want to subclass to reuse functionality. And that's what we're going to be talking about next, okay? Right now. Okay, any other questions? Yes? William.
What about when you want to alter a superclass and it's already got a subclass?
Yeah, good. Yeah. So suppose that you are the folks who maintain java.object, and you want to evolve java.object, right? You want it, maybe you want your superclass to use more efficient algorithms internally, or maybe you want it to use more efficient data structures. You want it to add methods to it, new methods, right? Could you do those things within the bounds of the Liskov substitution principle?
Yeah, as long as if new methods, there's basically nothing, no limitations, and then improving existing methods is all good as long as you can guarantee that post-improved conditions.
Right. Okay, in terms of promises, you can do it, right? So as long as the subtypes are counting only on the promises made by the supertypes, you should be able to do this, assuming that your promises in the supertype are not binding you to the certain algorithm. You have the freedom to change it. You describe what you're guaranteeing and not how you've accomplished it, and the subtypes shouldn't be counting on that. In terms of the Liskov substitution principle, but William's question is the perfect segue into the next issue, which is about superclassing, which involves more than the Liskov substitution principle. So I'd like to transition to this, and we'll come back to this. So, ladies and gentlemen, when I say that subclassing involves much more than subtyping, what am I talking about? What else does it involve? What else is, if you subclass something, which is probably for your case most of the subtyping you've done, what else does it involve beyond subtyping? What else do you get with subclassing beyond the ability to pass around a B as an A? Why else do people do a subclass?
To use A's function somehow?
Yeah. To reuse its implementation, to get all those goodies that went into programming A, so that you don't have to program them a B. Program them again in B. After all, you could declare B as a subtype of A, but in the sense that it can be passed around as an A. Think about declaring a class as a subtype of some interface. You implement that interface. You can pass it around as the interface, but does that automatically give you a full implementation of that interface? If I have an interface in Java, and I declare this class which implements this interface. Do I get a full implementation with that? No. I don't get any reuse of code or methods or fields. Instead, I can pass it around as if it's an instance, as if it's instance that captures, that adheres to that interface. But I don't get the implementation. With subclassing, we do. If we say this class is a subclass, B is a subclass of A, that certainly guarantees the compiler assumes it's a legitimate subtype in the sense that we can pass around a B as if it's an A. But it further has B, and we use the word inherit the mechanisms of A, meaning that if there's an instance of fetch in A, what does B have automatically? A fetch. If there's a foo method in A, we have a foo method in B. If there's a field in A that foo depends on, there's a field in B. Right? In other words, if there's a variable in A, we can reuse it in B. OK. So here, folks, we are dealing with something more than subtyping. We get subtyping. The compiler assumes that B is a legitimate subtype of A. And we have to guarantee that. No two ways about it. If we're going to pass around a B as if it's an A, regardless whether it's just a subtype or a full subclass, we got to be able to, it has to be consistent in its behavior. But there's more than that. We're getting these implementation details. We're reusing the implementation of A. Now, why is this significant? OK, I want to be sure that the people in the room are rock solid on one issue. And I've discovered that students sometimes emerge from 270 with a little bit of uncertainty about this area. I just want to be very clear. OK, so we have an A, and then we have a B that extends A. It subclasses A. And you'll notice that there's a bar in A, and then there's B overrides bar, class B. Okay, it overrides it, and it's the at overrides with the annotation, and it creates its own implementation of bar. And now we have some client class which has a B, and it's calling b.foo. So B doesn't define foo. A defines foo, and foo calls this dot bar. Whose bar is going to be called here? Indeed, B's. It's the most specific bar, the bar in the most specific subclass here. We have a B. A has a bar, but this instance, in A here, it's calling off to this dot bar. But if we have a B, B is overridden bar, so it's calling the bar in B. Does that make sense?
Yeah. And then if we wanted to use class A's bar for some reason, we could just do super.bar.
Correct. We could do super.bar. OK, so if anyone is uncertain about this, please let me know, or I'd be glad to meet with you in office hours, because I know this isn't sometimes explained really fully. But this is absolutely key to understand properly how subclassing works and how it works in Java and many other similar languages. So if anyone's feeling a bit queasy about this, no shame, just come talk with me, and we can work through some examples. But you need to be rock solid about this to make sense of what I'm going to be talking about. OK? So here we have the superclass A, a subclass of A called B. B overrides bar. And even though this method, which is only an A, foo, is calling bar, it's calling off to the most specific bar, this subclass. We're dealing with a B here. So when we call foo, it calls off to foo. And when foo calls bar, it's calling off to the bar and B here. OK? People comfortable with that? OK. So we're going to build on this. So we're calling off to bar. OK. So let me ask this. Building on our knowledge of subtyping, help me understand, folks. Is this a legitimate subtype? So I have a hash set here. which is it has some history properties. It maintains the set S internally and conceptually. And it has an add and an add all. And then I have a subtype of this where I declare add all. And you can assume that those have the same preconditions and postconditions. And all I do is I add another method that's called getAddCount. And it returns the number of times I've added something to this set. Is that legitimate as a subtype? Yeah. So again, add and add all, you can assume that they've got exactly the same preconditions and postconditions in the half set. Is that legitimate? Yeah. All I do is I provide this getAddCount. Yeah, I haven't changed the function at all. I've extended it by providing something that returns a little bit more value, but I haven't changed anything in terms of the promises. Okay? People comfortable with that being legitimate as far as the Liskov substitution principle. In terms of the promises offered, yeah. Good. Okay. Now, I'm going to say that, by contrast, in the presence of subclassing, that this is risky. And here I'm going to give an implementation of this instrumented half set. And I'd like you to tell me why this is a risky implementation of instrumented hash set. So here's this getAddCount, which just returns this getAddCount. Can anyone see where addCount? It's this internal variable that's being maintained to keep track of the number of times add has been called. And for add, we add 1 to it, because we're adding a single thing into the set. And for add all, given a collection, we're just going to add the number of items in that collection to addCount. So why is this code potentially suspect? Kurt?
Is it because if this is a B, and if they're calling add on that masquerading as an A, then it doesn't increment add count?
So say this again.
So if this is a B,
then
B.add does what you need and everything is good.
Yeah.
But if this B is being treated as an A someplace, then when it goes A.add, if it uses the wrong function add.
Oh, no, because we do actually want this is.
But you're overriding add or something, aren't you?
Yeah, we're overriding add, and that's fine. It has the same promises as in the super type. Secretly, this is the add we're being used. We think it's a hash set, but it's secretly one of these, and it's maintaining this extra information. So why is that a problem? Yeah.
You have it stored as a B. Couldn't some other code that has nothing to do with B explicitly call the super add function of B?
Explicitly, you're saying call the. Well, if there's an instance of an instrumented hash set, they're thinking as just a hash set, and they call .add on it, what will it call?
Oh, it would call that, but could they say we're going to call the super types add?
In most languages, you would not be able to do that. So I don't think that's a risk. Alex?
Add count is included before you even know if the super.add works.
Okay.
That's with that implementation, even though the add might have failed, it's a set. You can't add that object that's already in there.
Okay. Actually, this thing, if you keep on adding a value here, it's going to just happily. I see what you're saying. Okay, that's actually a really interesting point in the sense that, but the definition of this. So I like the way you're thinking, but actually the definition is the number of times here, number of insertions into. Okay, that's an interesting point I didn't pick up on. So the question is it already in the set? Fair enough. But there's something else that's broken, that's potentially broken. What is it? Ladies and gentlemen, this is counting on how this is implemented, not just in the promises, but how it's implemented. And in particular, where is it counting on it? Well, let's suppose I told you, folks, that add all in the superclass calls add. Whose add is it going to call?
Its own add, and it'll increment a crap ton of times.
Yeah, the phrasing would have been different for me, but you got the essence of it.